When the densities of a radon measure exist almost everywhere, then the tangent measures belong to an interesting class of measures called uniform measures. In this video, we'll give an overview of what these are and some examples of what they look like. Simply put, a measure mu is said to be S-uniform for some non-negative number S if the measure of any ball centered on its support is equal to a fixed constant times the radius of the ball to the power S. So some obvious examples of uniform measures are Hausdorff measures restricted to d-dimensional planes. Surprisingly, however, there are actually some nonlinear uniform measures. In particular, if we look at surface measure restricted to the three-dimensional boundary of the cone in R4, then this is an example of a three-uniform measure. While there's no full characterization of uniform measures, we do have some partial results. Notice that even though these results are partial, they're still quite non-trivial results. So first of all, one can show that all one-uniform measures after translation, rotation, and scaling by a constant are equivalent to one-dimensional Hausdorff measure restricted to the real line. And similarly, all two-uniform measures are equivalent to planar Lebesgue measure. Furthermore, Kowalski and Price have shown that any codimension 1 measure is equivalent to Hausdorff measure restricted to a plane crossed with the three-dimensional cone that we defined on the previous slide. And these results were the state of affairs for nearly 30 years, and no one had any other non-trivial examples of uniform measures beyond these cones. However, in 2016, in his PhD thesis, Nimer gave the first examples of higher codimensional nonlinear uniform measures. While he only shows how to construct the following class of uniform measures, the methods can actually be used to construct many other different families. Now, we've exclusively been talking about uniform measures of integral dimension. And the reason this is because of a theorem of Marstrand's that says there are actually no uniform measures of fractional dimension. They all have integral dimension. And we'll prove this theorem using tangent measures in a later video.